Hello everyone, welcome to my session. In this video, we will talk about phases of query processing. The Udacity course on SQL does a very good job at giving you a brief introduction about the concept of database, how to create tables, how to query data from tables, concept of views, etc. This particular session will help you understand what happens when you fire a select query. Let us have a look at it. So first we will build the query. I'm going to use the AdventureWorks database. The screen that you're seeing right now, that is a screen of a SQL Server Management Studio. It is a Microsoft product used to manage all the SQL Server tools. Uh, the variant of SQL that is used by Microsoft SQL Server is T-SQL or Transact SQL. You might be using MySQL or even Oracle database, and there will be slight differences in the way your SQL query might work. However, SQL has certain SQL standards that almost all the database has to follow. However, according to those standards, each database has the leniency to decide certain things by themselves. So implementation of certain functions, certain functionalities might be different, but by and large things will remain same. And if you are able to query a data in one SQL database, you should be good enough to query the data in all the other databases as well, which uses SQL. So I'll give you some very brief introduction about the AdventureWorks database. AdventureWorks is a sample database which comes along with a SQL server, and it allows you to demonstrate various functionalities. We will be using that. We can expand this node and we can see that there are database diagrams, tables, and views. And then there are many other things which are not relevant to this session. Let us just start building this query to understand what we are going to talk. So the first thing that we are going to do is we are going to select all the columns from human resources employee table. And start from now this you're seeing some suggestion, and that is because the SQL Server Management Studio has something called IntelliSense, which kind of try to predicts what you might be typing. Uh, it is good to use when you really want to write a long, huge number of lines of code. So let us run this query and see what we get as a results. Okay, so we have around 290 rows here, and as you can see, it is about the information of the employees that work at some particular company. Now here I want to give you some briefing about this asterisk mark. Asterisk mark is a very convenient way to pull the data from database. However, it is not a good practice. That is because, first of all, it is kind of lazy. Every time when you use star mark, you're basically pulling out all the columns from the database, and sometimes you might not need to do so. The idea is to request only those columns from the database which are absolutely needed. Otherwise, you can face certain performance issues when the scope of your work goes up. For instance, right now we are just having 290 rows. What if you had a million row, and it will take more time, pull more data. Now, the next step is to count number of males and females. And once I'll build the query, I will explain why I'm doing this. But let us just build this query together first. Count number of males and females. So what we will do is we will say gender, and then we will say count, and say gender as count from this, and we want to count number of males and females, so we will group this by gender. Let us execute our code. Excuse me. So there are 84 females and 206 males. Now, if we go back to the previous result, we can see that I will just run this query again for you to see. I will select this line and I will execute this. So uh, we can have the marital status, and I want to filter out people who are married. I'm filtering them out. So my results set should only have people who are single. So from this, we will use where clause, where marital status is equal to s, and you see that the count has changed somewhat. Now we want to modify the query so that you can see number of males and females who are single. Okay, and I need to add something to this along with the departments. So basically, I want to have information about each department. How many females are there in that particular department who are single, and how many males are there in that particular department who are single. To do that, we will have to include, and let us have a look at this results once more, and we can see that uh, there is a job title. Um, we can use job title to see the job roles, and we'll go ahead and type job title, comma, gender. And let us just try to execute this, and we should see an error. And I want to discuss why we are seeing this error. And this is one of the common mistakes that happen when we try to run a query which has a aggregation of some kind. I'll comment this out just so that we don't have to we don't run both of them by mistake. The mistake says that column human resources to employed job title is invalid in the select list because it is not contained either as an aggregate function or the group by class. Now, since we are aggregating by gender and we are giving job title, we need to include job title uh, in the group by class. Just run it now, and we can see um, that we got the results correct. And finally, I will try to use having count gender greater than 1. So I want the query to return only those results where count is greater than 1 for the particular gender for particular job title. And here's the result. Let us just add one more class, order by count. And the better practice is to put this into square brackets, D is equal, or you can use a single quote like this. I would go ahead with square brackets because I'm used to that, and order by count. And here are the results, and with count being going from lowest to highest, that is ascending, and you can supply a DESC to change the order from ascending to descending. Now here is an interesting thing. when you read the query, we read the query as select from where group by having an order by. But when SQL starts executing the query, it starts executing from clause. From clause, it picks up the information about which tables are to be included in the execution. If there are any joins involved, it will include information about the joins. Then it moves to where clause, where it will filter out the row according to this comparison. If this comparison, it is called predicate logic. So your whole SQL system works on two foundational things: set theory and predicate logic. From that, you get a relational database, and based on that, this entire SQL and all the other variants of SQL, like T-SQL, works. And so it sees that wherever marital status equal to S returns true, it should return you that row. Then it goes for grouping, that group by everything, and then having. Now, there is a distinction between where clause and having clause, and there is, on the face of it, it looks like both of them are doing the same filtering operation. However, there is a distinction. Where clause is executed before grouping is performed, whereas having clause executed after grouping is performed. So where clause filter out the rows before grouping is done, whereas having basically filter out entire group. You see, when you say having count gender greater than one, the entire group, because now this each row represents a group and not a most granular data, it is a group data. And having clause will remove that entire group. The rule of thumb to remember here is you cannot use aggregation in a where clause, whereas to use aggregations you have to use having clause and then order by count. Another interesting thing here is this, and I will just show it to you. We are using this gender as count, where let us try to use this alias as count here. And for now, yeah, I'm fine. I don't want to filter on marital or let us just retain this filter and add another clause. I will just not, I will just try not to use having for now, and I am trying to filter based on this alias over here. And I will try to execute this, and it's an invalid column name count. However, when I use this count alias in order by, it doesn't give me an error. The reason is, after executing having, select statement is executed. Order by is executed at last. So since the select statement is executed before the order by statement, uh, the database engine is aware about this alias. Now it knows that count gender is renamed as count, and that's why it is able to use it during order by. However, when where clause was executed, select statement was yet to be executed, and that is why we see this discrepancy. That's why you can always use aliases in the order by, but you might not be able to use it in any of these statements. So this is how the basic operation would work. Now let us just add some tricky questions to this. Here you see, when you said marital status equal to S, the answer was yes or no. The answer was never unknown. I'll just show you what I mean by that. If you look at the marital status column here, it always has some value. You never had a null here. Now let us try to build this query on another view. Select all the columns from human resources dot we employee. Again, asterisk mark is not good practice. It is fine during data exploration, but when you're building a final query, for production or for reporting system, it is not a good practice to use this. Okay, so let's start from human resources dot we employ. Again, this particular query is we are querying this information from a view, whereas the previous query, this one, we were querying the information from table. Now, let us just discuss the difference between table and a view. A view is a virtual table. If you want to have a look at how views are formed, we can do that by looking at the source code of the view. And I don't want you to get into too much details if you're not comfortable, but it is basically a select statement, a simple select statement which can join multiple tables and everything. And it is just created, it is just saved in the form of view. So excuse me, so it is a sort of virtual table from which you can query the data. And so basically you can bring in multiple tables into one view, and now you don't have to join these tables every time. You can just treat that view as if it were a table. One of the reasons why you should always use views while querying the data and not the table is because views can be secured, whereas tables for most part aren't. Views can have a row level security by defining some kind of filtering over here. So if this data is coming from some software, views will be secured. And so let's say if you are making some report out of a view, there is a way you can retain that security. But table, that security can be bypassed. Okay, let us build this query. Uh, what we will do is we will try to query the middle name, all the middle name, which has letter L in it. Select middle name from human resource dot we employ, where middle name like, and this is a wildcard. So it basically says that query all the middle names which has letter capital L in it. This percentage is, it will check for everything before it, everything after it. So it can have like it will result for if something was stored in this form. Oops. So let's say there was a string like this, it will return it. If there was a string that starts with L and has so many blanks after that, it will return it. Or if we had something like this, a string with some numbers and some alphabets, that will also be written. So practically anything that has L in it can be written. We can have a separate session on pattern search and wildcards, but for now, if you do not understand it, that's fine. All you need to know is this query returns everything, every middle name that has letter L in it. So you can see L, Lee, Oliver, and then William. And you can see that this is not case sensitive because William, the L is lowercase, but still it is written. Now, let us just ignore the where clause and rerun the query. So you can see that there are nulls present in this particular column. Now, here is the interesting question. When where this wherever this value is written true, in other words, if L is found, the results are returned. So when it tries to find L in null, that null is not written in this full query because um, L is not there in null, it's null. But then what happens when we say not like null? And do you think null should be returned or null should not be returned? Intuitively speaking, you might feel that query should result all the query should return all the results which does not have L in it. Let us see if it does so or not. And you can scroll down. There are 255 rows. Uh, but what happens is nulls are not returned. So why is that? What is happening? Even when we say not like L, it is not returning the null because a null is handled as a special case in a predicate logic. So when you say select, when you say when you give a where clause, and in case of null, it doesn't return true or false because null in SQL is unknown, and when unknown is compared to anything, it is still unknown, and that's why it is always eliminated from the result. And that is why you have to be very careful when you are dealing with null about how you want to return the result. You have to remember where clause will always filter out the null. It will not return because where clause will return results only if the condition is true. Whenever null is present, condition is not true, it is always unknown. Okay, now let us just remove this where clause and run this query again. One thing to note is the order of the results does not necessarily have to be in any particular way. Every time you run a query, you can get a different order. There is no set implementation which says that you should get a particular order unless you are enforcing it using order by clause. Again, what do you think should happen to nulls? When you say order by middle name, obviously it will be in alphabetical order, but what happens to the null? Should they be in some particular order? Should they be in the beginning or should they be in the end? Let us just run this and see. You can see that all the nulls are written at the top and then starts letter A and then B and then C. That is how SQL Server has implemented returning of null in the order by clause. And this might change based upon the database system. And here the assumption is it is in ascending. If you change to descending, you see it starts with Z and then you will have all the nulls at the bottom. So this is how the phases in querying works, predicate logic, where clause, order by clauses work. This is important for you to understand, especially the case of null, so that you do not make any mistake while running a report or something. Now, this is just a tip of an iceberg. As we move further, we will have so many different cases, such as date time, uh, because date time, the way we format things changes country to country, and there can be lots and lots of confusion about how to handle a date time, and you have to be very careful. I can have a dedicated session on that, but this was just to give you an idea about how the query unfolds when you return it. It is important for you to remember the order so that you can effectively decipher the query in your brain, and compare the results once you see them on screen, so that you can check if that makes sense to you or if you're missing something. I hope you found this session useful, and see you in the next session. Thank you.